Hello, my dear friends or my dear student. Welcome to my channel called Sunflower MS Institute. Okay, in this video, I want to discuss about the equation from chapter number 9. Okay, you can see these are the important equation I collect from chapter number 9. Okay, before going to derive to this equation, okay, at first I want to suggest you that you have need to study in proper way because of you are the student of class 12 and this is very important stage, okay, or critical stage. If you able to cross this stage, then you able to get your target point. Okay, so my dear friends, these are the certain some equation from chapter number 9. Okay, you have need to focus on it, but you have need to study in proper way each and every subject or every lesson. Okay, for smart study, okay, I collect this. So my dear friends, you can see this is the first equation called the relation between the center of the curvature and the focal length. Okay, which about I already discussed, okay, in the previous lecture, I mean lecture number 1. Okay, also mirror formula I will discuss, but in this video I am only cover this third one, okay, called refraction through the spherical lens. Okay, so my dear friends, to derive this equation, you have need to understand that what do we mean by refraction, yes or no, and Snell's law. So refraction means what? Let's say this is a surface and this is air and this is called, let's say, water. This is a rarer air is a rarer medium, okay, as compared to water. Okay, this is called denser medium. This is your cute surface. Okay, let's say the light ray comes from the source. Okay, comes from the source. When light rays, it has property of a refraction. Okay, excuse me. When light rays come from the rarer medium to denser medium, okay, it go the close of normal. Okay, it will slightly bend towards the normal, and this is called incident ray. This is called what? Excuse me. This is called incident ray, and this is called reflected ray. Yes or no? And angle between the normal and the incident ray is called incident angle, and this is called, and angle between incident refracted angle and the normal is known as what? Refraction angle. Okay, okay, this phenomenon is known as refraction. Okay, so my dear friends, now begin. Okay, our main topic, to our main topic. Main topic is what? Refraction. Refraction through a spherical refracting surface or curved surface. Okay, please write with me. Refraction through a spherical refraction through a spherical what? Refracting surface. Refracting surface. This surface I will consider here convex mirror. Okay, convex mirror. Okay, as for your NCRT. Okay, so to derive this equation, I mean refraction through the spherical surface, this equation, okay, will be mu1 by v, okay, here is negative sign, plus mu2 by v is equal to mu2 minus mu1 is divided by r. R is called what? Radius of the curvature. Okay. So to derive this equation, to derive this crucial equation, okay, we have need a protector by which I am going to draw a convex mirror. Okay, so my dear friends, I want to turn the pages. Okay, okay, this is a convex mirror. This is convex mirror. Okay, this is convex mirror. Okay, and if this mirror is like that, okay, this is called what? This is called concave mirror. Okay, cap, like cap, okay, curved surface. So this is called concave mirror. Concave mirror. Okay, and this is convex mirror, which our main hero. Convex mirror. Convex mirror. Convex mirror. Okay, so this is a ray. Okay, this is a ray cross through the midpoint of convex mirror called what? This is called principal axis. What do we mean by principal axis? Okay, which line join, which line, okay, which line pass through the pole and the center of the curvature is known as principal axis. You can see. Okay, so my dear friends, let's say this is your object. This object is, you must be considered as a point of source. Okay, when light rays comes from the object, okay, and incident on the convex mirror, okay, after reflected back, after reflect, okay, it will bend towards the normal. So we have need to draw a normal. So normal is must be drawn from what? Center of the curvature. So let's say this is center of the curvature. Okay, this is normal. Okay, why you draw like that? Because of, let's say this is a circle, yes or no? Let's say this is your what? A convex mirror. If you increase the line, then you able to get a circle. Okay, then you able to get a circle. Okay, you have need to consider. Okay, excuse me. So this is a point, okay, of circle. When you want to draw the normal, you have need to go by perpendicular making. Okay, when you making the perpendicular, then it must be go through the point of circle, then this is called the normal. Let's say if you want to, okay, perpendicular, but you go like that, so it is not perpendicular. Okay, this is not perpendicular, this is called tangent. Okay, so if you want to draw another normal, but you go like that, it is go like that, it is not made the perpendicular or normal. So you must be go by making the perpendicular with the surface, then you are able to get the target point, and it is called considered as what? Normal. So this is a normal, this is a center of circle. If you increase, okay, extend this, then you are able to get a circle, okay. When the light ray comes from the source, and this is called incident ray. Okay, and the incident ray bent towards the normal. Okay, this is called what? Mm, then you will get here what? Image. Yes or no? Then you will get a image. So this angle is referred to as I mean angle of incident, and this angle is called what? Angle of refraction. Yes or no? So another thing is that you have need to remember, when you measure, okay, all the distance, then you, okay, then you think that I am stand here, okay, and all the distance must be measured from the pole, okay, from here, okay, from here, okay. So the distance between center of the curvature and the pole is called radius of the curvature. Yes or no? This is image. This is called what? This is called image. Yes or no? This is called image, and this is called object. But in this derivation it is not important, it is not requirement. Okay, let's say this is a ray, this is a ray, go towards direction. Okay, if you go with this ray, then you take the value, all the positive value, okay, all the positive value, this all the positive value. So this is, you can take as positive value, and this ray go like that, and you measured like that from pole, okay, from pole to object, but the ray of object go to the opposite, then you write all the value in negative sign. Understood? Okay, let's say this is a rarer medium. Okay, this is what? This is a rarer medium, and let's say this is denser medium. This is called what? Denser medium. So this point is okay called you can say M. Okay, so for this you have need to draw a normal, okay, to the principal axis. Okay, this okay, let's say this point is N, this MN or MP are nearly equal, okay, or N or P are same, you can say. Okay, so for derived this equation, very key equation, very important equation, very important equation, you have need to consider some angle, okay, some angle or small angle. Okay, let's say this angle is called what? Small angle, let's say alpha. Okay, attached to the principal axis, you have need to consider angle which is attached, okay, which is attached to the principal axis. Also this angle is attached to the principal axis. Okay, let's say this is called gamma. Okay, this is called what? Gamma. This is called gamma. Let's say gamma like okay, so this is like to some, okay, so okay, this is R, this is, let's say, gamma, and this is beta. Okay, so you can hear Snell's law. Applying Snell's law, okay, applying Snell's law, applying Snell's law or rule. Okay, applying Snell's law, this is a rarer medium, the refractive index mu1, and this is denser medium called refractive index 2. Okay, this is denser medium of the mirror. Okay, all the glass here, all the glasses, okay, glass. So denser medium, this is rarer medium. Rarer medium is, okay, I take mu1 here, mu2. Okay, so when ray go to the point of the mirror, okay, then you can write here, mu1. And according to the Snell's law, you have need to write the sine, and when you able to get this point, I mean this angle is called incident angle. Let's say this is I, okay, I1, this is I, okay, mu1, I1, mu2, I2, R2, okay, refracted angle. Okay, okay. So it is equal to what? When you go rarer medium to the denser medium, then you must be write that mu2, refractive index of the denser medium, I mean second medium. Yes or no? And sine, or you write here R2. Okay, okay, okay. So you can write mu1 I1 here, mu2 R2. Why you cancel here sine? Are you know? Don't worry, I am here. Okay, let's say this is sine theta. For a very small angle, you can write sine theta is equal to theta. Okay, and this theta must be what? Very small, is very small, very what? Small, very small. Okay, and let's say for a small angle you can write tan theta also, theta. You can write for a very small angle, I mean very small theta, sine theta is equal to or nearly equal to of tan theta. Okay, okay. So my dear friends, to derive this equation, you have need to take triangle or object among the triangle. So first we have need to take the triangle from OMC. OMC. Let's say this is an object. Okay, this is an object called OMC. This is a triangle. OMC. OMC. Okay. OMC. This is a triangle. Okay, triangle OMC. From triangle OMC, we can write. Okay, here main second target is what? At first we find out her Snell's law, yes or no? And second important thing is that we have need to find out, okay, I1 and then R2. Okay, okay. So you can write, and two is it, and we have need to find out here from this triangle I1. How you find it? I1 is equal to what? You can write alpha plus alpha plus what? Alpha plus gamma. Alpha plus gamma. Are you able to get? If you, okay, if you add to internal angle, okay, the sum of the internal angle, mind it, the sum of the internal angle, okay, is equal to the external angle of third angle. External angle of third angle. So don't be confused. Okay, let's say this is a triangle. Yes or no? This is a triangle. Let's say this angle is A and this angle is B. Okay, when you add two angle and this angle, the sum of the two angle of the triangle, the sum of the two angle of the triangle of the angle is equal to the external angle of the third angle. Okay, so A plus B. So let's say this is angle I, this is alpha, and this is what? Gamma. So you can write the I is equal to alpha plus gamma. Okay, don't be confused. Let's say this is equation number 1. Okay, and to derive we have need to take another triangle, and triangle is what? MIC. You can see here MIC. MIC. This is another triangle. Okay, this is another triangle MIC. From triangle MIC. Okay, another triangle. This is very disturbance. I want to remove from my hand. Okay, excuse me please, my friend. Okay, okay. So you can write here same formula. You can apply the same trick. Okay, like that. Okay, your target is R2. Yes or no? Your target is what? R2. Your target is what? R2. So if you add beta and R, if you add beta and R, then you able to get the third external angle. Okay, third external angle. Then you write. Okay, then you write. This is called gamma. Okay, this is called gamma. Gamma is equal to beta plus R2. Okay, this is the internal. This is the two angle of internal. Okay, and when you add, okay, then you able to get the external angle of third. Okay, the sum of the two angle of the triangle, okay, is equal to what? The external angle of the third. Okay, so from this you can find out, what? R2. R2. Yes or no? So R minus I'm really sorry, this is gamma. Okay, gamma, don't be confused, gamma minus beta. Okay, so from Snell's law, okay, these are the value R. Okay, I1. Yes or no? You have need to just put the value here. So Snell's law, okay, you able to get the value of I, you able to get the value of R. Yes or no? Okay, now you have need to put the values. Okay, so Snell's law, mu1 I1 is equal to mu2 R2. So what is the value of I1? Mu1. Okay, I1 alpha plus gamma, and is equal to mu2 gamma, plus, sorry, gamma minus beta. Okay, so this is called this is gamma. Okay, this is gamma, these are gamma. So another thing is that you convert into tan alpha. Why? These are the small angle. You have need to consider, as small angle. Yes or no? Small angle. So for small angle you can write, tan theta is equal to theta. Yes or no? Sin theta is equal to tan theta. So similarly, this is very small angle, like that. This this is very small angle, so this theta nearly is equal to tan theta. So like that, if here you have need to remind here, that tan theta if tan theta is equal to theta, then tan alpha is equal to alpha. Then you can put the value. Okay, put the value of alpha here. So mu1 tan alpha plus tan gamma is equal to mu2 tan gamma, sorry, minus what? Minus tan gamma. Okay, okay. don't be confused, my friend. So from this you have need to find the value of 10 alpha. What is the value of 10 alpha? Okay, 10 alpha p by b, yes or no, perpendicular by base. This is alpha, and here diagram is also alpha. So p by b, yes or no, perpendicular by base. This is a perpendicular from this triangle. Okay, perpendicular is what here? This is perpendicular mn, yes or no, mn. So mu1 you can write, you can write what? Mn. Mn is divided by what? Base. Base O, you can see here OP. Okay, OP plus 10 gamma. 10, this is gamma, 10 gamma, perpendicular by base. This is perpendicular Mn and base what? Nc. Okay, you can write M Mn is divided by what? Nc. This is perpendicular and this is base. Okay, is equal to mu2 10 gamma. Okay, similar, you can put the value Nc minus 10 gamma, minus 10 gamma, minus 10 gamma. Okay, so what is the value of 10 gamma? What is the value of 10 gamma? You can see here gamma. Okay, 10 gamma perpendicular by base. So here perpendicular mn, yes or no, here perpendicular mn and base is ni, and base is mn is divided by what? Ni. Okay, okay, so you can observe here that mn are common, so you can take the common. Okay, or divide, okay, with mn. When you divide in the both side with mn, then you are able to get 1 by op plus 1 by nc is equal to mu2. Okay, mu2 is equal to 1 by nc minus 1 by ni. Okay, now, okay, our answer is near, don't worry. Now we have need to do one thing, that value of op. What is the value of op? Here op, you have need to find out the op. op I'm really zero op, this is the distance. Okay, you have need to measure all the value from the pole. Okay, you go, okay, here to there. Okay, then this is called what? This is called object distance. This is called object distance, and this is called, and from distance from pole to image is called image distance, yes or no, image distance is called v. Okay, so value of what? op u. Okay, and nc what? Nc, okay, nc call r. Okay, just we have need to put the whole value u plus 1 by r. Here similarly mu2 1 by nc. Here nc means what? nc means R, okay, and 1 by Ni, 1 by Ni. This is Ni. This Ni you also write the Pi. Pi. Why? Pi. Okay. Ni and P is nearly each other, so that's why from P to I is called what? Is called image distance. Is called image distance. Ni is equal to what? Pi. So it is nearly is equal to V. Okay. So you can write mu1 is equal to 1 by V1, okay, plus 1 by 1 by R, 1 by R, mu2 is equal 1 by R minus 1 by V. Okay. So here 1 by R and 1 by R is common. Yes or no? So you can write okay, like that, plus mu1 by R and mu2 by R, also minus 1 by mu2 by V. Okay, mu2 by V, and mu1 u, okay, plus you can write mu2 by R and mu2 by R minus mu1 by R. I'm really sorry, this is V. Okay, so mu1 u plus mu2 by V is this 1 by R is common, 1 by R is common, so mu2 minus mu1 you can write, so mu1 by u, object distance, mu2 by what? V is equal to what? Mu2 minus mu1 is divided by R, and this is your final, okay, equation. So my dear friends, I am very work hard for you, okay, based on what I know, however I want to give you. So my dear friends, you are the only one who can support me. So my dear friends, dear students, please subscribe me, share, okay, so that I can provide you more further video. Thank you.